In this video, we're doing another example of multiplication with polynomials. And up until this point, we've only multiplied polynomials together that had the same number of terms. So, for example, we took two binomial terms like this x minus 2, a binomial term meaning there's two terms involved, one is x, one is negative 2 here, and multiplied two binomials together. So we have the same number of terms in both polynomials. But in this particular example, we have a different number of terms across our polynomials. In this first one, we're dealing with a trinomial. There's three terms involved, 3x squared, negative 2x, and negative 2. And we're multiplying that by another polynomial. This one happens to be a binomial with two terms. So I just want to clarify, what do we do when we have two polynomials that we're multiplying together with a different number of terms? Well, the most important thing is for us to be systematic about our multiplication. It's really no different than what we've done before. We just have to make sure that we multiply every term in one polynomial by every term in the other polynomial. So let's be organized about it here. We're going to start with 3x squared, the first term in the first polynomial. So let's look at 3x squared here. We want to multiply this by each term in the other polynomial. So it's like the FOIL method in the sense that we need to multiply every term in one by every term in the other, but we just have a different number of terms. So 3x squared times x is going to give us 3x cubed. When we do x squared times x, we get x cubed, so 3x cubed. And then 3x squared times negative 2, we need to make sure we include that negative sign, times negative 2 gives us a negative 6x squared. So we've multiplied this first term by every term in the other polynomial. Now we want to look at negative 2x, the next term in our first polynomial. So negative 2x times x is going to give us a negative 2x squared. Then taking negative 2x times a negative 2, the negatives cancel and we get a positive 4x. Now we look at the last term in our first polynomial, which is a negative 2, again, as always, including that negative sign if there is one. And we say negative 2 times x gives us a negative 2x. Negative 2 times negative 2 gives us a positive 4. So notice how, because there's two terms in the second polynomial, we end up with two terms for each term in the first polynomial. And that's because we take each term in the first polynomial and multiply it by each term in the second polynomial, which is going to give us two terms in our result. So now this polynomial is all one polynomial together, and we just need to simplify it as much as we can. What we're looking for are like terms, and that's going to be terms with the same base and the same exponent. So for example, x squared, the base is x, the exponent is 2. Here we have a negative 2x squared, the base is x, the exponent is 2. We'll be able to combine those. So we start with 3x cubed. Well, there's no other x cubed term in our polynomial, so we leave that as is, 3x cubed. Then we take negative 6x squared and negative 2x squared. Well, these are like terms because the base x is the same and the exponent 2 is the same. So then we just add the coefficients. We say we have a negative 6 of them and a negative 2 of them. That's a negative 8 of them, so we say negative 8x squared. Then we look at our x terms here. We have 4x and a negative 2x. Well, the base is the same, x, and the exponent is the same. These are both x to the first power, x to the 1 and x to the 1. We just don't write the 1 because it's implied. So these are like terms. We can combine them. We have positive 4 of them and negative 2 of them. So 4 minus 2 gives us a positive 2. So we end up with plus 2x. And then positive 4 here is the only whole number, so we can't combine it with anything, and we just leave it as positive 4. And we can't simplify any further, so that'll be our final answer for the polynomial. So the idea here again is just make sure that you're organized about how you do the multiplication and multiply every term in one polynomial by every term in the other polynomial, and you'll get the right answer.